All right, so we're going to take a look at the quotient rule from geometric and numerical perspectives. And I realized that I didn't have anything on the playlist, and I think we can take a little quick peek at this, and hopefully what I'm about to do makes some sense. All right, so be helpful if you already looked at the product rule in the playlist. So the product rule, length times width equals area, gives us kind of a one-sided limit approach here. Where you get L prime W plus W prime L as how the quadratic four-sided figure changes. All right. Numerically, looking at the squaring process, it's in a lot of the other videos. We can see, I'm going to be concentrating when x equals 3. We can see that 3.001, get that a little lower. 3.001 yields 9.006, 001. Significant change, 0.006 divided by significant change, 0.001 gives us that 2-to-1 ratio. And that's why the derivative of x squared is y equals 2x from a geometric and a numerical perspective. So let's play with this product a little bit. And let's let y equal x. Our area is going to be x. And the derivative of that we know is 1. So y prime is 1. I'm assuming if you're looking at the quotient rule, you've already done power rule and done some work, a little bit of work with derivatives, so we can go there. And so if we divide area by width, we get length. Okay, so if I have x squared and I multiply it by 1 over x, I get y equals x, and it's kind of following this geometric trajectory here. I don't know if I want to call it that, but the jingle for the quotient rule, I assume it's out there. Low D high minus high D low over low low. So if you got a fraction, function divided by a function, then low is the denominator, D high, derivative of the numerator, will give us what's over here, dn prime minus nd prime over d squared. Okay. But in this case, we're really multiplying the area times 1 over x to get that length, to get that other side length. And the number should work out. If we work this out, it should come to a derivative of 1. Well, let's find out if it does. All right, so x squared divided by x equals x. And that's the same thing as x squared times 1 over x. All right, so our denominator is 1 over x, which could also have been expressed as x to the minus 1. Okay, I'm capturing all of this, that's fine. So hopefully that picture makes some sense. Already talked about watching the power rule. So let's draw our situation. And then let's just manipulate it with what we know about the derivatives of each function. All right, hopefully this is coming out all right. So derivative of x squared is 2x. In other words, this side length when x equals 3 is actually a length of 9. And 2 times x is 2 times 3 is 6. And x to the minus 1, whose derivative is minus 1 over x squared, using the power rule and expressing it in that fashion might be the easiest thing to do. And so that is actually at 3 minus 1/9. So we're actually cutting away area on this drawing. Okay, so let's throw the numbers in. Yep, got everything. So when x is 3, 1 over 3 is this length here, which is the same as this length here. And 1/3 times 6 is 2. And when x equals 3, this side length is 9. Let's see, we're really cutting in here because the derivative of x to the minus 1 is minus 1 over x squared, minus 1 over x squared. And when x is 3, we get minus 1/9 change. So it's actually moving in this direction. Times 9 is minus 1. And I do believe if you add minus 1 to 2, we get 1, which I think is the derivative of y. Y prime is 1. That's the change. And I do believe that's the derivative of y equals x. And x squared over x equals x. And x squared over x is x squared times 1 over x, which equals x. And it all matches up. Okay, so I just wanted to throw that out there. as at least a representation of what's going on. I'm a firm believer that you have to see numbers work or you don't understand the rules. And with COVID now, a lot of students coming in without understanding rules for fractions. So for instance, I'm just saying for instance here, if a student doesn't know how to multiply a couple of fractions, you got to start with something you know. 2 times 3 is 6. 2 could have been written as 4 over 2, 3 as 9 over 3, and hopefully the rule can be seen to work. Right? And I think you got to do the same thing with calculus and e to the x and ln of x. I think you got to crunch numbers. And the more you crunch numbers, better chance you have to see patterns. And the more you see patterns, the more you understand what you're doing. All right. So I hope that makes some sense and I hope it helps someone. So I'll post it. And I guess I'll end the video now and push stop.